world's best bottle rockets. We'll see if I can take it up to about 80 psi. 90. Let's try 90. Here we go. Where'd it go? Oh, wow. Hand pump's difficult, but we're going to try and get it up to 100. It's not easy with a hand pump. Done it before. With a compressor, you can get 120, 140, 150. These Coke bottles, they hold a heck of a lot of air. A lot of pressure without having to blow up. Yeah, cool. Get a little more. Hang on. All right, so now that you've seen the rockets launch and seeing how screaming high they go, I want to try and show you how to build them. I've been doing it for about 20 years. I used to teach science at Savannah High School in California before I moved here to New Zealand. And I've seen a lot of posts on YouTube about building and launching rockets, and I think in many ways I've built a better mousetrap for some very practical reasons. I've stayed pretty low tech and low cost. So let's start with the bottles. You can use your simple 2-liter bottles. You can use your 2¼ liter bottles. You can use 3-liter bottles. And basically your rocket, if you've never built it before, is just 2 bottles put together. A bottom bottle that's intact, that's going to have to withstand the air pressure being pumped up to anywhere from 80 to 140, 50 psi. Then you've got your second bottle, which you chop off and use for your nose cone of this. Now you see I bought a little football off of AliExpress because I do these at camps, and they come down quite hard, and I don't want it to kill anybody. You can also see I put a little tennis ball in this to act as a ballast. That is a weight, because without the ballast, your drag going up is going to be too much or overcome the momentum. The drag pushing down or pushing against it is not going, it's going to overcome the momentum unless you put some more weight in it to give it the momentum. All right, here we go. So you've got to take off the label, otherwise your fins are not going to stick. And I do call them fins, not wings. Wings are shaped like an airfoil. Fins are just with no camber in them, a foil like that. So you put that, and I've made, again, a low-tech bottle rocket holder. Makes it a lot easier to glue things and hold things when you do that. So take that off, and then you can begin to determine whether you're going to have just two bottles that are there, or one longer, one shorter. This is obviously 1, 2, 3, 4, and I've painted half of it orange and half of it not, and I've just glued these together, and I'll show you how to do all this stuff. You'll notice something else. These fins are very straight. This rocket is going to fly straight and true. These fins, you'll notice, have an angle to them, and so this will spin, as you've seen when I launched this, and I've painted it orange and green so you can make it more dramatic. So we get the bottle. Next thing we do is determine our fin material. Now, there's something specific that I choose to use, and it's called core flute. The realtors here in New Zealand use this stuff to advertise, and it's polypropylene. It's weather, UV resistant and stuff. And it should be an obvious reason why I use this stuff. It's pretty strong, very durable. And I mean, if I take and bang this stuff on the table, it's still good. Hardly munted at all. Very durable. But the main reason I use this, pulling this, I have a bucket of water. You see the water that's been sitting in water. If you try to do that with regular cardboard or any other paper product, you'd be munted. And there's going to be a lot of water as you fill these bottles with the water. They get wet. Without the core flute, you'd be able to use them 3, 4, 5 times at the best. These, you can use them for years. So we choose the material here. And from then on out, you just measure and cut this stuff. So pretty easy. Just cut down a line here with my blade. Never cut towards yourself like I'm doing here. I'm just cutting a quick rectangle. If you wanted to, you could pre-mark it with this, same difference. But cut what you want out of there. I'll probably get half of that. I'm just making this up as I go. Quarters out here. You'll see what I'm going to do. I'm just going to make some small rectangles here. Cut it into small rectangles, and then take your rectangles and take them in half and cut them into triangles. Now, I've noticed that I've cut this one a little bit smaller. Some people have massively gigantic fins. Some people have small. These are a little bit smaller than I actually want. I want it to stick out a little bit further from the side, more like this. But I just wanted to give you the idea how easy it is to cut up this core flute. You need at least 3. 4 is okay, 5, 6 is okay, but at least 3 to stabilize it in all 3 directions. What do I mean by that? Where's the... well, that's got 4. You've got stability in all 3 directions here. It's not going to wag back and forth. If you only had 2 fins, like one here and one here, put it like this. If you only had 2 fins, like so, this bottle would be stable like this. It wouldn't go like this, but it could go like this. Okay, so they stabilize in different directions. So you need at least 2, 3, 4, 5 is good. Here's my stand again. So once you get your fins, I've seen people use tape and whatnot, and again, it doesn't hold very well. This PVC, this liquid nails that you can get for about $5, $6 a tube, at least here in New Zealand. This liquid nails, whoops, just run it down the side, stick it on there, and like we say here in New Zealand, Bob's your uncle. When that thing dries, you're going to be able to bang it on the table, and it's going to last. It's going to be good. Okay, so this is where your stand comes in handy. You look across, you level out your eyes and put it right across. I'm going to go with 4 fins there. Then I'm going to estimate a perpendicular 90-degree angle. Put a little glue on this fin and eyeball. Matter of fact, I don't have to guess. I'm going to stand up and look straight down on there. And when you're looking straight down on it, your eyeballs can tell. Can you see that all right? You can tell if your fins are lined up, making sure that it's not going to go on all wonky or be on the wrong side. I can't really put my head in the way, but I'll guess it right here. There we go. How's that looking? For straight, looking down on it. I can't really tell. Can't have both a camera and a head at the same time, but looking for where I am, I can see this one needs to go down, that one over. And so I would keep looking down from there. Then next, I would go ahead and get another bottle and figure out which one I want to have to put on the top. And it's pretty easy to cut these. Put a mark, and then you take and cut them with your scissors. That way you get a nice straight line. I'll cut this right on the bottom of the label. What do I have here? Tonic water. Now I will glue that on there, but not yet. Okay? I told you I needed a ballast. This bottle is way too light. It wouldn't get the momentum to travel as much as I wanted it to. So, 2 types of ballast. You can use a golf ball, glue it in here, or you can use any old munted up tennis ball and glue it in there. And it's pretty simple. Use a bit of a guess. I'll just put a few marks on here. It doesn't take too much. put there, and I'll make sure my glue is down, and I will drop it in. There we go, and I'll make sure I push it in a little bit on this one. It's nice and wedged. I'm happy. And I'll take this and I'll just put it around here, around the inside edge, just like that. Just liquid nails. I guess I could have put a better tip on that. And then I will smash it together. Now I could also put a bead around the outside. What I want to do is always check for trueness to make sure everything's nice, straight, lined up. Because as you would have seen how fast they go, if they are bent in any way, they're going to angle over. They're not going to fly true and straight. This one should be a good rocket, ready to go. Let the glue dry for about 24 hours. 48 would be best. That stuff, if you ever dealt with liquid nails before, you know that stuff glues hard. And like you already saw me banging those fins against the table, it's going to be good. Okay, now the launcher. That's the crucial part where you can really muck it up with that one. As you can see, my launcher is pretty basic. This is 1/2-inch PVC pipe. I'm in New Zealand now. Can't really get this. I think it's 12 mil or 15 millimeter. Not too crucial. You just want your pipe to be able to fit pretty snugly into your bottle. That fits pretty good. Okay. So I've got 3 of these end caps, 1/2-inch end caps, one on there. So something else that occurred to me is this may not be obvious what's been done. I've got an end cap, again a 1/2-inch end cap that'll insert on the end of the pipe. Before you glue that onto the pipe, you need to drill a hole in that so that this will fit in. You go down to a tire shop. Tire shops will definitely have these. They'll usually give them to you. They might sell them to you for $2. They're easy to get a hold of. So you get a 1/2-inch drill bit and drill a 1/2-inch hole right in the middle of this, and then you stick it through from the bottom up. I've got 2 T's, right? 1 T for that, 1 T for that. Again, 1/2-inch right there. I added just an adapter, a coupling rather, to make it a little longer. You can make this as long as you want, so you can keep as dry as you want, but this is more portable and easy to store. You can also get these little stakes from garden centers and just peg it down so that it'll stay stationary out there on the grass. When you pull it, sometimes it's a tug and it'll cause things to move. So we'll keep it like that. Now, I guess you can also use, if you want, you can use a hacksaw to cut this stuff, or you can use one of these. It's just a ratcheting tool that when you ratchet it down, it makes a nice straight cut of your PVC. Okay. Now, for years, the problem was getting the rocket under pressure to stay on here and not lose pressure. While this seems snug, it's really not that snug. It'll lose pressure there. My trick used to be to try to get that thing to slam down on that coupler. I tried putting silicone and whatnot, and then trying to keep it down on here. I'll show you how I do that later. But I found that these screw part necks are slightly different, and so my pin holding mechanism didn't hold it as snug. I found a much better mechanism. As you can see, I've got a little gasket there. That's the beauty of it. It fits very snug, and I'll try and wet it. I'll moisten it here. Try and wet it down. There we go. Until it fits just, boom. Okay, that's a little bit low. I want it right about there. I could fill that up once I get it latched on. I can fill it up to 100, 150 PSI. It'll stay there for 5 minutes without losing any pressure at all. So that's the beauty. So let me go ahead and show you my launch mechanism. I've obviously got a T here, and I've got a small piece in there, and this coupler right here. That's a coupler. That's what you're seeing there. Then, for this piece, all I did was I took an angle grinder, okay, a little bit from an angle grinder. I put it on my vise, and that's the tricky part. I just started by hand rubbing that around to get a groove of the right depth. It is a trial and error process. It should look about like that, about that deep. You might think, well, where did you get the gaskets? I think off AliExpress, I got this entire little gasket kit for like $8. Not sure if Home Depot or Prep Boys or whatever auto store, but you get the gaskets, get a gasket set, and then it'll slide right on there. I might have gotten one that's too big. They're hard to get back out once you get them in, but you slide it in there, and then you get your bottle, and it's just trial and error. Do I need it deeper? Do I need it wider? And once your gasket is good, you're good to go. And that's why I say this doesn't have to be exactly 1/2 inch. Okay, not all pipe is created equal. You've got schedule 40, schedule 80. But at the end of the day, as long as your gasket is a snug fit, and again, let me wet this. I'll wet that out and this, because these rockets are going to be wet, and you can hear and see. I'll be quiet with it. Not too much pressure, just snug. That's all you need is snug. There's the beauty of it. Now, the launcher. You've got to get something to hold this in place, right? And so I'm using pins. That's why I just went to Home Depot, the hardware store, and got a bunch of adapters. Where's my adapters? I just bought a bunch of them. A whole bag of stuff to figure out what I could use to put together, to try and tie together, that would A, allow the bottle to fit in, and B, allow me to put the pins in. And so I found, I'm not even
Good to go.
Okay. I didn't want to just leave it up to chance. This is a 1 1/4 inch pipe. This is a 1 1/4 to 1 inch reducer. This is what it looks like. Again, at the time, I just picked up a bunch of stuff that might work. Put that in there. Get another one. This is slightly different. It's got something in the middle, but just the same principle. Put it in there. That goes on top, and again, I just fill the rest with some bushing type material, and when it fits on there, again, that's not quite the right type, that'll work. And then you just drill your holes in it. Okay, so 1 1/4 to 1 1/4 to 1 inch reducer, and that'll get you done. And as you can see, I have my PVC cement that'll work. You glue them all together. Okay. But bottom line is, you see I cut that so that it slides in and out, and it does. Put it over the top. I get the distance right, and then I put this clamp, put the clamp on there, clamp it on, and it seems to hold just fine. But the stopping mechanism is right here in this. Your bottle goes in. Your clamp, you can use, if you don't have any of these, you can just use a bent over coat hanger. You can use 2 or 1 like that. Hang on, there we go. Put that in a little bit more. There we go. There. It'll go all the way through if I push it just right and push it hard enough. And then when you pull it, it obviously locks it in. It's not going anywhere. When you pull it, it obviously flies out. The puller I saw, the one you saw out there, I just decided, do I even need 2? I just put 1 on the side. And when I get it all clamped down, it's still pretty tight. Pull the nail out. Boom, there you go. So that's the beauty of it, is this O-ring that keeps the pressure in, and your kind of makeshift locking mechanisms. I've seen people that needed machine shops to machine this, that, and the other, and servo mechanisms and mechanical claws. And this seems to be the cheapest, the most low-tech, and it seems to be the most efficient, and you've seen what the rockets do out there. So good luck in building your rocket. I think I've covered just about everything you'll need. They're pretty safe, especially if you put any kind of, plasticky, styrofoam on there. I remember launching them at school. Sometimes they get close to kids. I've had hundreds of kids around hundreds of rockets, and knock on wood, I've never had a kid get clobbered by a rocket yet. But I do have the safety mechanism for the millennials.